Okay, absolute value function. Okay, absolute value function, when the y or fx here equals to the modulus x. So the domain of the absolute value function y here defined for all the values of x, and the domain of the absolute function here is all the real numbers between negative infinity to the positive infinity. Okay, and then the second, the range of the absolute value function x here defined for all the value of y, and then the value of y here start at the origin, and the range of the function here equals to the 0 to the positive infinity. Yeah. Okay. First, when fx here equals to the modulus x, so first part of the function, fx here equals to the x, and then x here, or domain of the function, greater than or equal to the 0. And then second function here, fx equals to the negative x, and then value of x or domain here less than 0. Okay, so when you plot all the point, so the vertex of the function here start at the origin, x0, y equal to 0 to the positive infinity, first function here, and here start at the origin here to the negative infinity. Yeah. Okay, question 5. Determines the domain and the range of the following function. Fx here equals to the modulus x plus 2. Okay, first step, you write down the modulus function, modulus x plus 2, and here you write down in a piecewise. Okay, so first part of the function here, fx equals to the x plus 2. Okay, and the domain of the function here, x greater than or equals to the negative 2. So you let the function here, x plus 2, greater than or equal to 0. And then the domain of the function here, greater than or equals to the negative 2. Yeah. And the second part of function, negative x plus 2. So this one, you just put the negative sign. Okay. And then here, the value of x here less than negative 2. So this one is x here plus 2. Okay. And less than 0. And x here less than negative 2. Okay. Okay, so first part of the function, when fx here equals to the x plus 2, and domain of the function here greater than or equals negative 2. So this one is the first part of the function. So you draw the tables, and the first value of x here equals to the negative 2. This value you substitute into the function. Yeah. So you substitute here. Okay. So when x here equals to the negative 2, and value of y here equal to the 0. Okay. And then you plot all the point. X here negative 1, y here equals to 1, and here 0, 2, and x equals to 3, y here equals to the 3. Yeah. Okay. Okay, settle first function, and here is tables. Okay. And then the second function here, fx equals to the negative x plus 2, and then domain of the function x here less than negative 2. So less than negative 2, the first value of x here start at the negative 3. Okay, so first value is negative 3, negative 4 to the negative infinity. Okay, so this value you substitute into the function. Okay, so you find the f negative 3. Okay, so first one here, x negative 3, y here equals to 1. And then second, negative 4, 2, and here negative 5, 3. Okay, and then you plot all the point. Okay, okay, so this one, you draw the y-axis, and you draw the x-axis of the function. Okay, first function, when the fx here equals to the x plus 2. So first value here at the negative to 0. So this one you label. Okay. Then second value x negative 1, y here equals to 1. And here is 0, 2. And here equals to the 1, 3. Okay. And then at least 3 value here. So you draw the straight line to the positive infinity. Okay. Okay, and then the second function fx here equals to the negative x plus 2. And the first value of x here, negative 3, 1. This one put here. And here is equals to the negative 4, 2. And then last here, negative 5, 3. Okay, you put here. Okay. And then you draw the straight line to the positive infinity. Okay. Ya. Yang ini kelas ini sebab saya punya exist ni tak cukup, nanti you all boleh sambung. Okay. Okay, and then graph here. Okay. So this one the graph of the absolute value function. This one you label axis, y-axis, x-axis. And here you put the arrow to the positive and negative infinity. And then from the graph here, you find the domain of the function. Domain of the absolute value function here is all the real numbers, negative to the positive infinity. Okay, and the range of the function start at the 0, y equal to 0 to the positive infinity. Okay, so you start at the 0 here to the positive infinity. Okay. Okay, question A. Fx here equals to the modulus x plus 2. And question B. Okay, question B, modulus x minus 1. Okay, this one, question B, your exercise. Okay, question B, your exercise, modulus x minus 1. So first step here, you write down the absolute value function in a piecewise. Okay, so the first function here, x minus 1, and the value of x here greater than or equals to the 1. And the second part of the function, negative x minus 1, domain here x less than 1. Okay, and then tables. First table, fx here equals to the x minus 1. Okay. Okay. And the second table is here, fx equals to the negative x minus 1. So you find the value of x, find the value of y, and then you plot all the point here, and you sketch the graphs of the solid value function. And last here you find the domain and find the range of the function. Yeah. Okay. So this answer. Question B. Okay. And vertex of the function here at the 1 0, and then the y-intercept of the function here at the 0 1. Okay. Domain of the function is all the real numbers negative to the positive infinity, and the range of the function start at the y equal to the 0 to the positive infinity. Okay. Okay, question 6. Sketch the graph of each of the following function and state its domain and the range of the function. Okay, question A, fx here equals to the x plus modulus x. Okay, first step, you write down the function. Modulus fx equals to the modulus x. So first part of the function here, fx equals to x, and the domain of the function here greater than or equal to the 0. And here negative function fx here equals to the negative x here less than 0. Okay. And first part of the function, when fx here equals to the positive x, so this function you substitute into the fx. Okay. So here equals to the x and the plus x. So first function here fx equals to x. Okay. So this one. So I write down here. Okay. And then the second part of the function, uh, fx here equals to the negative x. So write down here. Okay, so you substitute into the function x plus modulus x, and here you replace with the negative x. So x here plus negative x, and function here fx here equal to the 0. Okay, so you write down the function fx here equal to 0, and domain of the function here x less than 0 here. Okay, settle. Okay, and then the first function fx here equals to x, and the value of x here greater than or equal to the 0. Okay, so you draw the tables, value of x, and here is a value of y. So the first value here, x greater than or equal to the 0. So first value here, x equal to 0, and you substitute into the function, and value of y here equal to 0. Second, 1, 2, 2, 4, and here equals to the 3, 6. Yeah. Okay, and then the second function fx here equals to the 0. Okay, and second function fx here equal to the 0. This function represent the constant function. Okay, so when first value of x here equal to the 0, first value of x here equals to the -1. Okay, so this one you cancel. You can substitute any value -1 and the value of y here equal to the 0, -2, 0, -3, and y here equal to the 0. Okay, you can choose any value of x and the value of y here equal to the 0. Yeah, and then you plot the graph of the solid value function. Okay, so you plot all the point here. Okay, so first part of the function fx here equals to the to x, and domain of the function here x greater than or equal to 0. So you plot all the point here at the origin 0, 0, 1, 2, 2, 4, 3, 6 to the positive infinity. Okay, and then the second function fx here equal to the 0, and then domain of the function here less than 0. So first value here -1, 0, -2, 0 here, -3, 0, and here equals to the -4, 0. Okay, so you draw the horizontal line between infinity to the x equal to 0. Okay, and then the first function here fx equals to the x here. Okay, settle. Okay, okay, here is the function. Okay, settle. Okay, yeah. Okay, so from the graphs of the absolute value function, you find the domain, find the range of the function. Okay, so domain of the absolute value function here is all the real numbers, negative to the positive infinity. Okay, and the range of the function start at the 0, y here equal to 0, and to the positive infinity. Okay, settle. Question A. Okay, and question B. Okay, question B, fx equals to the modulus x plus 4. Okay, and first step, you write down the absolute value function here in a piecewise. So first part of the function, fx here equals to the positive x. Okay, and the second order function fx here equals to the negative fx. Yeah. Okay, and first function here you replace, you substitute into the fx. Okay, so fx here equals to the x plus 4 and domain of the function greater than or equal to the 0. Okay, this one first part of the function, and the second here negative function, negative x. Okay, so you replace. Okay, and the second part of the function negative x plus 4, and then the domain of the function here less than 0. Okay, settle. Okay. Okay, and then the tables. Okay, so tables here start at the x greater than or equal to the 0. So first point of x here start at the 0, 1, 2, 3 to the positive infinity. Okay, so this value you substitute into the function, and then the value of x here, fx equals to the 4. Second here equals to the 5. Here equal to the 6, and last here equals to the 3, 7. Yeah. Okay. And then the second function fx here equals to the negative x plus 4, and domain here x less than 0. So this one you substitute into the function. Okay. So you find the f negative 1. Okay, ada technical problems. Okay, kita teruskan. Okay, so you plot all the points negative 1, 5, negative 2, 6, and negative 3, 7. Okay, and then you plot all the points. Okay, so here is the y-axis of the function. So you draw here y-axis, and here x-axis, and you graph here to the positive infinity, and here to the negative infinity. Okay, and the vertex of the function here start at the 0, 4. Okay, and then you plot all the point 1, 5, 2, 5, 3, 7 to the positive infinity. Okay, this one start at the negative 1, 5, negative 2, 6, and negative 3, 7. Yeah. Okay, and then you list down state the domain of the function. Domain of the function here, all the real numbers, negative to the positive infinity. And the range of the function start at the y here equals to the 4. Okay, start at the 4 to the positive infinity. Okay, settle. Okay, question B. Okay, that's all.